This is Saturn I, one of the launch vehicles for Project Apollo. Mated to it, a prototype of the spacecraft designed to make the first manned flight to the moon. This unmanned flight will gather essential information unobtainable by any other means. In the blockhouse, men are watching every aspect of the launch, men responsible for its success. A short distance away, other men are watching, men who will one day fly a similar spacecraft.
10 seconds. 8, 7, 6, 5, 4, 3, 2, 1, 0. Lift off.
Each astronaut has been carefully selected. This is part of their preparation for their own step into space. For the astronauts, the first step takes place in the classroom. Their instructors are a cross-section of the nation's leading engineers and scientists. Briefing sessions and formal classes acquaint them with the equipment and theory of spaceflight. This academic program lays the foundation for their development as astronauts. The next step is to instruct the astronaut in piloting a spacecraft. In the weightlessness and vacuum of space, the problems he will encounter are unique. The most important single aspect of his training is flight simulation. In the Gemini Part Task Trainer, the astronaut practices various parts of Gemini missions, including orbital attitude control, re-entry, and the ultimate goal of Project Gemini, rendezvous with a target vehicle previously placed in orbit. The most critical phase of rendezvous in space is the last 100 feet, docking the spacecraft with it. This is practiced on the Manned Spacecraft Center Translation and Docking Simulator. The astronaut flies a full-scale mock-up of the Gemini spacecraft to a docking with the Agena, the target vehicle used in Project Gemini. The astronaut experiences the visual and control conditions he will find during actual space mission. As spacecraft pilots, the astronauts must be prepared for contingencies occurring before or after space flights. Since the returning Gemini spacecraft will land at sea, they receive egress training to cover any emergency situation. Should a mission be aborted on launch or after re-entry, the astronauts will eject from the Gemini spacecraft and land using their personal parachutes. Training is given to cover this eventuality. The unscheduled termination of a mission could force a landing in a number of types of terrain. Survival training is given to enable the astronauts to subsist in an unfamiliar environment. Their survival kits contain no food and only the essential tools. The astronauts must learn to live off the land using these kits and their parachute. Survival training is conducted in the jungles of Panama and the desert of the western United States. After appropriate instruction, they are left on their own for 2 days. The astronauts, more than spacecraft pilots, are destined to be the first human explorers in space. The moon is their objective. Knowledge of geology is essential to meaningful lunar exploration. Field trips complement classroom theory. Geological formations are observed firsthand. The astronauts become familiar with the basic tools of exploration. The geological techniques learned on Earth will be used to examine the airless surface of the moon. Although the general training program is continuous, after the initial phases, each astronaut is assigned to an area of the manned spaceflight program. Often he serves as an evaluation engineer. This is a study of controls for the Lunar Excursion Module, the vehicle which 2 astronauts will land on the moon. the astronauts tested the hand controllers for operational qualities. As the men who must use this equipment, their findings are invaluable to the men who must design it. In this capacity, the astronauts attend design engineering inspections. These inspections present designs of spaceflight hardware. It is important that the astronaut be aware of the latest configurations and advances if he is to function at maximum efficiency in the manned spaceflight program. Most of a spaceflight mission will be spent in weightlessness. This state is produced for short periods of time inside an aircraft flying a parabolic trajectory. During certain Gemini missions, an astronaut will leave his spacecraft and step into space. The astronauts work with engineers to develop methods of exiting and entering the spacecraft while weightless. During other tests, an astronaut evaluates the optical guidance and navigation devices he will use to help navigate his spacecraft on the way to the moon. The spacecraft must function not only in space, but on the Earth after its flight is done. Astronauts served as test subjects during Gemini post-landing seaworthiness qualifications in the Gulf of Mexico. For 17 hours, the astronauts rode the pitching, rolling spacecraft. While they checked out spacecraft systems, instruments on the tending ship monitored their condition and the condition of the spacecraft systems. At the end of this test, the spacecraft was qualified. The subjective and physiological reactions of the astronauts provided new data for the development program. The testing of Gemini biomedical instrumentation is another area requiring astronaut participation. This includes biosensors, tiny instruments taped to the astronaut's body. During space missions, biosensors pick up the astronaut's physiological reactions, which are transmitted to Earth. This test required the astronaut to wear the Gemini pressure suit. He did not remove it for 8 days. The first 3 days were spent in jet aircraft flights, producing both weightless and high-gravity conditions. The astronauts' physical reactions were monitored and recorded. The next 4 days were spent in a mock-up of the Gemini spacecraft. This approximated the duration of a manned orbital mission. On the final day, the astronaut underwent high-acceleration re-entry simulations on the human centrifuge, duplicating his return from spaceflight. After the acceleration runs, the biomedical equipment was removed, the checkout complete. The participation of the astronauts in these development programs produces knowledge contributing to the exploration of space. On the day an astronaut is named to the flight crew of a specific mission, he is relieved of his previous areas of responsibility. His activities are now focused toward one goal, the success of his specific mission. This is his purpose, his reason for being an astronaut. The briefing sessions he attends now deal with specific mission details. His evaluation activities are now centered on the spacecraft he will fly. Throughout the construction, he participates in systems checks and evaluations. He becomes familiar with every critical detail. His reactions are important to the men who design and build a spacecraft. The astronaut's survival depends on the reliability and operation of vital spacecraft systems. In space, the astronaut's decisions must be quick and precise. In the Gemini mission simulator, a complex computer-driven trainer, he flies and reflies the coming mission. The interior of the crew station is a detailed duplicate of his spacecraft. The astronauts rehearse every step of the coming spaceflight. Difficult or critical portions of the mission are gone over many times. By constant practice in the Gemini mission simulator, the astronauts learn to react rapidly and correctly to any situation. The astronauts are prepared for their role in the exploration of space. General training lays the foundation. Engineering participation builds on this foundation and contributes to the development of manned spaceflight hardware and techniques. Then the ultimate stage of the astronaut's pre-flight activities, preparation for a specific mission. When the day of his mission dawns, the astronaut is ready for his step into space.